So, yesterday we learned about nets. So, today we're going to learn about cross sections, okay? Now, how many of y'all ever put a block of cheese on your sandwich? An entire block of cheese. No, you don't. Because what do? You have to slice the block to get a slice of cheese, right? Or maybe it's already previously sliced, right? So basically what we're learning to do is slice the cheese or cut the cheese. But it's not really cheese. So here's the deal. Cross sections is all about just cutting 3D figures and getting a little slice, okay? So a cross section is the shape made when a solid is cut through by a plane. Do y'all remember what a plane is? What's a plane? In math, geometry, first week of school. What? Flat surface, right? A plane is a flat surface with no thickness and extends forever in every direction. So that is thin enough to slice anything. So we slice a solid and we get a shape. So cross sections are usually parallel to the base, but they can be in any direction, okay? Now it's kind of cut off right here, but up there you can see on your worksheet on the top right, that's a cone that you slice in different ways, and the different ways you slice it can give you what's called conic sections. Conic means cone, sections means slices of that cone. So, okay, so number one, okay, you can see this figure. We have a pyramid, yeah, and it's being sliced parallel to the base. So you see the plane, this rectangle right here, slicing through that pyramid. Now I want you to notice, what's the base of the pyramid? We'll call it a square. Kind of might be a rectangle, but either way. When you slice parallel to the base, you end up getting the same shape as the base. So look right here. You see how when it was sliced up here, it also made a smaller rectangle, okay? So again, when we slice it parallel to the base, it's going to make a thin slice that's two-dimensional. So again, 3D, cut it, 2D. And you can see it over here as well. Okay, this is a different aspect of the same thing, but the base is a rectangle. When I slice it, I get a rectangle, okay? So, number two. Now, again, the concept, actually first, let's answer number one. The answer was what? What is the cross section we got? We'll call it a rectangle, okay? Again, you take the 3D shape, you do the cross section, and then you tell me the name of that 2D figure when you slice it, right? So, number two, what's the base of number two? What's the base of number two? A circle, okay? So, now, when we cut parallel to that base, what are we going to get? It should be the same thing as the base, right? So, boom. If it's parallel to the base, it is the same as the base. Number three, what is the base shape? A hexagon. So, parallel to that hexagon, number three would be what? A hexagon. It's going to be really small and hard to see up here, but rest assured, it matches the base. Now, number four is a sideways prism. What's the base of this prism on number four? A triangle. So parallel to that will also be a triangle, right? And number five, if you take any sphere and you slice it any way, what do you get? A circle. again, you're looking for a slice that's two-dimensional, it would be a circle when you cut it, okay? So far, so good. Now, if all you had was parallel to the base, it'd be easy, 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 okay? Sometimes we don't cut parallel to the base. Sometimes we cut vertically. When you read these, you have to look for key words. So let's read number 6 for key words. What is the cross section? Formed by a plane containing a vertical line of symmetry. That means it's going to cut vertically. Now you tell me, vertical is which way? Up and down. So this is almost as easy as the base one. You just got to tell me what shape you see up and down on that prism. So up and down, what shape is that? This is up and down, and that shape is a rectangle. So if I slice it anywhere else, I should also get a rectangle. So let's say we cut it straight down the middle like this. It would go straight down, go over, straight up. That is a rectangle, right? But you wouldn't know that unless you read carefully and you saw the word vertical, okay? So the answer here is rectangle. Now, same picture. Number 7 is asking for the cross section formed by a plane that is what? Parallel to the base. That's like numbers 1 through 5. What do I know about parallel to the base? Same as the base. So what is the base here? So I got a hexagon. And then if I cut it anywhere else, I would also get a hexagon. Okay, so hexagon. All right, now I want you to visualize this with me. Vertically on a prism, we see rectangles. So vertically, when you cut it, it's a rectangle. I want you to imagine, because it's not on the page, what if you have a pyramid and it says to cut it vertically? What do you see vertically when you look at a pyramid? A triangle, right? Because all the sides are triangles on a pyramid. So again, if you cut vertically a pyramid, you see a triangle. What about a cone? Let's say you got a cone. What do you see vertically when you cut a cone? Triangle, okay? So think about it. It's pointing at the top, and at the bottom it's wider. If you cut it vertically, you're going to get a triangle. So, and what about a cylinder, okay? So let's try that on number 8. 8 says, what is the cross section, let's circle that, formed by a plane containing a what? Vertical line of symmetry, okay? That's my key word, vertical line of symmetry. So that means I'm going to cut it vertically. So if you're not sure about the cylinder, look right here. If I cut it vertically, that would be along the edge, straight over, straight over. What is that shape? That's a rectangle. If you cut a cylinder vertically, that is definitely a rectangle, okay? Now what about number 9? Same picture. What's the cross section formed by the plane that is parallel to the base? What's the base shape of this? Circle. So if I cut it anywhere else parallel to that, I would get a circle. So far, so good. Kind of easy, maybe. Well, let's make it harder. All right, flip it over, please. Flip, flip, flip. Now we're going to take these cross sections, whether you have a rectangle or a triangle, and we're going to rotate them and spin them and make them look cool like that. All right, so let me show you what I mean. All right, so it says we can rotate a cross section to create a new 3D figure, 3D object, okay? So if you see in this picture, if you got this figure and you start rotating it around this axis, you'll see that it's going to make a circle on the bottom and a circle on the top. And if you spin it fast enough, like this. Whee! See how fast it's going? To where it's such a blur, it would look something like this, where it's got a circle on the bottom and the top. What's that called again? A cylinder. So, it's typed out here. When a rectangle is rotated, it makes a cylinder. Every time. Rectangle or square. If you rotate it, you're going to get a cylinder. Okay? Rotate a rectangle, get a cylinder. Okay? Now, the one thing that's not on here that we need to know is, what if we are doing it with a triangle? Okay? So let's take this triangle, start rotating it real fast. The bottom creates a circle and the top is still pointy. What do you call it when the bottom is a circle and the top is pointy? A cone. Okay? So let's write that in here in this little space right here. What about a triangle? If you take a triangle and you rotate it, you will get a, we just said, cone. Okay? Oh, the R looks funny, so triangle. A little better. All right, so with that information, we're going to answer these last three. Each of these problems has 2 parts. You need to tell me the cross section and then what happens when you rotate it. Okay, so number 10. Find the cross section parallel to the base. So key words here. Cross section, is it vertical or not? Nah, because it says parallel to the base. What did we say about parallel to the base? Matches the base, right? Now we have no picture, but it tells us it's a right triangular prism. What is the base of a right triangular prism? It's in the name. Okay? You don't need the picture of it because it says it right there. Okay? If you're looking for the base, it's the first name of the prism or the first name of the pyramid. Okay? Now, if it said cone or cylinder, you would know, hopefully. Circle is the base, right? So here we go. We need to write down the answer to the first question. What's the cross section? A triangle. So cross section is a triangle. Cool? So remind me, if I take that triangle, put it on an axis, and I start rotating it, what does that make? A cone. Okay? So the rotation makes a cone. Cool. So does everyone see the 2 parts? Because right here it said we needed to rotate it. It's right there in the problem. Yeah? So first we cross section, then we rotate. All right? Now, number 11. Find the cross section parallel to the base of a square pyramid. What's the base of a square pyramid? It's in the name. What kind of pyramid? Square pyramid. So we know the base of the square pyramid is a square, so the cross section parallel to the base is also a square. Let's write that down. Cross section is a square. So obviously this can be harder if it talks about vertical cross sections, so be careful when you read it. Now again, if I put the square on an axis and I start rotating it around, what am I going to get? A cylinder. So from the rotation, it tells me to rotate it, right? Rotation makes a cylinder. Cool. And last but not least, identify the 3D object generated by rotating a semicircle. What's a semicircle? Okay, so let's say I got half a circle. I put it on an axis. That's not perfect, but whatever. I start rotating it. What would I get? Sphere, yeah? So the rotation is a sphere. Okay, so I know we have limited time today. I'm going to give you the assignment, and you're going to finish it tomorrow, for sure, in class, along with the first one. So tomorrow's your work day to finish those two assignments.